Hello, sixth grade Eagles. This is Miss Petty.
And this is Miss Towels.
And we are coming at you today with measures of center and variability. We're going to talk about the actual measures of the center and spread of a data set.
And when you get in 7th grade, they'll call it measures of central tendency, so you can have an idea of what that word is when you see it. So, our objective, did you go over the objective, Ms. Petty? No. To understand that the mean, median, and mode of a set of numbers of data are measures of center of that set of data.
Understand the range of a set of numerical data is measured by how the data varies. So we skip the first one. Understand that the data distribution can be viewed by its center, the mean, median, and mode, because we talked about the shape already. So now we're also going to talk about the center and the spread. So do remember the things that we talked about for the shape. At the end of our lesson, you should have mastered standard 6 SPA2. Understand that a data set collected to answer understand that a set of data collected to answer a statistical question has a distribution which can be described by its center, mean, median, mode, spread, which is the range, overall shape, and 6 SPA3.
Recognize that a measure of center of a numerical data set summarizes all of its values with a single number, while a measure of variation describes how its values vary with a single number.
So let's get into our vocabulary. The mean is the average of a data set, and you can find that by adding up all the values and then dividing by the total number of values.
And average is just another word for mean. So when you say the average score that Curry makes in a particular game, we'd be saying the mean score that points he makes in the game are the same word. You can use them interchangeably, mean and average. So you just want to make sure you understand that. And then the next word is medium, and it's the middle number in an ordered set of numbers or data. So it's just the numbers that are in the middle. So if there's an even set of numbers, you take the two middle numbers, add them up and divide by 2. But if there's an odd set of data, you just take the middle number, and that would be your median.
Right. So when you add them up and divide by 2, you're finding the mean of those two middle numbers. But be sure that you have the numbers in order. Because if they're not in order, you're just going to be finding some random measure, right?
Exactly.
And the mode is the most common number in a set of data. So that just means it's the most. The mode is the most, the number that appears the most. That's all. And
then you have the range, which is the difference between the largest number in the data and the smallest number.
Right. And
so subtract the smallest number from the largest number, and that would be your range.
Right. Because difference is our keyword, and I'm really hard on those operations. When you see the keyword, you should think about what operation you would use.
And difference is to subtract.
Right. So one. There we go.
Okay, so we have an example, and then we're going to solve problems 1 through 8. But of course, we're not going to give you all the answers 1 through 8, but we're going to give you the majority of them. So you have 10 people who were asked how much money they plan to donate to the new library fund. The answers were 20, 20, 20, 40, 40, 40, 40, 40, 40, and $100. What is the mean or average donation? So it says you can draw a graph that represents how much each person plans to donate. Then to find the mean, move the symbols to show what each person would donate if all of them donated the same amount. So with donations appear to be in increments of $20.
Right.
So you graph down here, and then you have the number of people. So what we did, they put dollar signs. So you have one person who donated. How many people you have? So you got one person who donated 20, then you got 2 people. So each dollar sign is represented by 100. So the question is, what is the mean donation? And explain how the graph on the right shows the mean.
Right. So the mean, when we look at the graph, scroll up a little bit. Just looking at our graph, the mean here is going to be $40. Because when they spread out the money among everybody, I'm trying to get this, everybody has $2 signs, and we know that $1 sign is $20. So $2 signs has to be $40. So, and that's how they show it. What they did, the reason they got to this graph in the first place is because they counted all the dollar signs that they had. The person who donated $100 had 3 extra dollar signs, 3 more than really everybody else. They took his dollar signs and they put them over here. So, and now there's an even number of dollar signs distributed among all 10 people. That's how we got to our new graph. And so they just have $40 among everybody.
Okay, so you see how that is? So that particular graph made it easier for you to determine what the mean was.
Right.
Where the first graph, you would have to do a little bit more work. So here's number 2, says, complete the equations to show another way to find the mean. So another way would be that first graph doing that, where you have 20 plus 20 plus 20 plus 40, 40. So you would take this first graph and put in everything, the number of persons, and then just put that in 40. So 4, 5, 6, 7, 8, 9 has 40. And then the 10 person had 1, 2, 20, 100, like they gave you originally. So then that would add up to 400.
Bring it down.
Bring it down. So 400 divided by 10 would give you 40.
Right. And that's how they got to it. Because they're saying if we put all the money together and then we divided it equally among the 10 people, it was $40 per person. So you put it all together, so added it up, and then divided it equally. All right. Number 3. Are there any outliers in the data? If so, calculate the mean without the outliers and explain how the mean is affected.
So the first thing you have to do is decide, is there an outlier? Is there an outlier in here? I would say, what would you say, Miss Petty?
I would say yes.
Yes. Now, the outlier is
100.
100. So what we have to do is leave 100 out, take the remainder of the data, add it up, and what number will we divide back by? How much data do we have now since we've taken out the outlier? Would be what?
9.
9. So now you add everything up. So we already know that the total was 400. So if we take 100 out, we know now the total is 300. So it's 300 divided by 9. And that's when you will get your mean, which is really, it's not
even
it's not the whole number.
Right. 300 divided by 33.33. So just if I was going to do that, I took out the 100. I have 300 there. Got 300 here. And we're going to divide by 9. And we're going to get 33.33. All that wonderful stuff. 33 and a third. So that's
all right. And you can get numbers, the mean or the average, with a decimal in it. So there's
right.
Some questions, the answer will be a whole number.
Right. So $33.33 per person, or 33 and a third. Now, how the mean is affected? Well, is the mean bigger or smaller?
It would be smaller at this particular point in time.
Right.
Because we took the outlier out, which was 100. So automatically, if you take some data away from a number away from a group of data, the mean is going to increase because you also have a small amount of data items.
Right. It's going to increase or decrease. It depends on what the number was. Now, say we took away all those 20s, and then the people are only donating $40 to $100. So then the average is going to be bigger, right?
Yes, the average will be bigger because you're taking away all the smaller numbers, and then you have the larger numbers divided by a less amount of data, which would be 1, 2, 3, 4, 5, 6, 7. So it'd be like 100 and
Let's see.
200 and something divided by 7, which would get a high number.
Right.
So that would be your mean, how to find the mean. And then you can do your independent work by yourself. And if you have any questions, you could email myself, Ms. Petty. Now we're going to move on to, is it the mode?
Median and mode.
Medium and mode.
Right. Study an example showing how to decide the center of a data set using median and mode. Then solve problems 1 through 8. So we are going to solve problems 1 through 3 together. And you guys can do 5 through 8 on your own. If you have any questions, contact us and we will help you with it. All right. A team scores for 10 basketball games are 46, 42, 43, 44, 42, 40, 42, 42, 44, and 43. Find the median and the mode of the basketball scores.
Well, the first thing, go ahead.
I was going to say, before we even look at the answer, we need to go back to our definitions of median and mode and think about what that means. Now, go ahead.
Okay, so the definition of median means it's the middle number. So the first thing we're going to have to do is put the numbers, the data, in order from least to greatest in order to find out what the medium is. As well as with the mode, sometimes you may have to put the numbers in order to find out the mode. Sometimes you will not, because the mode is the number that's repeated the most. Mm-hmm. But in any sequence, any circumstance, I would suggest, even when you're finding the mean, the medium, and the mode, is to always put the data in order from least to greatest.
Right. Because even when you look at the data set, that 42 is 4 of them, right? Yeah. There's that one that's over there at the beginning, and then 2 together. You will not be able to see the mode for big numbers like this. Unless right. Especially if you had a lot of them, you will lose one if you don't put the numbers in order.
So it's very important to put your data in order. I see sometimes when you do it, you're looking. No, put it in order from least to greatest, and then go out and start doing your calculations. Right. So the first thing we did is put it in order: 40, 42, 44, 42, 42, 43, 43, 44, 44, and 46. So it says the median score is 42.5. So you see that there was an even number of data. So what we do is we get the 2 middle numbers, which was 42 and 43, and that equaled 85. And then we divided by 2 to get the mean of the 2 numbers, which was 42.5. So that would be your median, which is your middle numbers. Right. Now, the number that appears most often in a data set is the mode. And the mode of this data set is 42 because we have 4 numbers that are 42 in this data set. You want to circle that for them, Ms. Petty, so they can see?
The 4? Mm-hmm. Yeah.
The 4 42s.
In a little box. We have 4 42s. Yeah. And then we're going to go down a little bit so we can still see the data set. All right.
Okay. Go ahead, Ms. Petty.
What would the median score be if 40 were removed from the set of scores? So
that's number 2. You didn't do number 1. Jason says.
Okay. Go ahead.
Jason says that more than half of the values of any data set are above the median. Is he correct? Explain. So the first thing you have to do is go what? You already know what the median is because they told us it's 42.5. Now go back to the data.
And the definition of median. Because he said half of more than half. So what is median? when we're looking for the median of a data set, what does that mean? It's exactly in where?
In the middle of the data.
The median is always exactly in the middle of the data. It can't be anywhere else but the middle.
So if we look at this, we see 43, 44, two 43s and two 44s, which are 4 data points, and 46, which are 5. So is he correct? Yes or no?
Well, we have 10. We have 10 scores, 5 on each side of our median. So is there more than half of them?
No.
No, absolutely not.
Not because the same number of values are above and below the median, because the median's in the middle, is the middle number. So we got 5 numbers below 42.5, and we got 5 numbers above 42.5. So Jason isn't right.
Right. So number 2, what would the median score be if 40 were removed from the set of scores? Now, that is a great remove because it's on the end. So now, in order to find the median, what I do sometimes is I actually like to cross them out or underline. So for this, I can highlight. So take off 1 here and 1 there. I think we have enough where I can take off 2 at a time. Then we have 1 more and 1 more. So I've taken away 4 numbers from the greatest scores and 4 numbers from the least scores, and I have 1 left in the middle because now this is an odd data set. So 1 number left in the middle. What is our median?
43.
Right. That was very, very simple. Just take off the numbers and leave the middle number.
Exactly. Especially it's easier when the items of the data are odd numbers.
Right.
You just take that middle number. So number 3 states, the line plot shows the basketball scores from above. Explain how the line plot shows the mode. So we see the lines plot over there. The mode is the number that's repeated the most. So we can just look at the line plot and say, hey, that's the tallest. That line plot right there at 42 is the highest, which is at its peak. So that would be the number with the greatest number of X's.
Right.
The mode would be right there.
Yeah, that's it. The tallest thing, it has the most X's, is definitely our mode. It's the on there. And then you guys will be responsible for 4 through 8.
4 through 8.
Right. And if you have
And so let's just discuss the range right quick. The range would be the least number from the highest number. So if we look at this group of data right here that we just did, the highest number in the data is 46, and the lowest number is 40. So when you subtract 40 from 46, your range would end up being 6.
Right. So you have a good recall for range because that is our last example. Range. So 10 people donated the following amounts of money at a school fundraiser: 5, 30, 10, 10, 5, 5, 20, 60, 20, and 15. These are all dollars. What is the range of the data? So just looking at it, you need to identify the biggest number and the smallest number. So let's highlight those. And these are not in order, but I still recommend that you put them in order, because what if you lost the number, right?
Then you would end up with the wrong answer.
Right.
So the largest number of people donated was what? 30, I believe.
No, it's not. See, they're not in order. 60.
60. Where is 60 at? Mm-mm.
So I highlighted the 5 and the 60.
Right. So it was 60. See how Ms. Towles missed that?
Right. Because it's deep in there. It's hard. This would be really hard to do if you just, what if it was 100 numbers on the page? I would have lost a few numbers. You need to have them in order. So range, once again, is the difference between the greatest and least values. It gives you an idea of how spread out the data values are. The smallest donation is 5 and the largest donation is 60. And the range is going to be 60 minus 5, so 55. And these example problems are just conceptual, really. Number 1, explain the meaning of range within this problem solution. So in order to explain something in the context of the problem, you need to go back to the problem and talk about what story the problem is telling. 10 people donated the following amounts of money at a school fundraiser. So when we're talking about the range in terms of the donations made at a school fundraiser, you basically tell the story. We have 10 people, and then of course it's amounts of money. They all have dollar signs, and this was a school fundraiser. The range here is going to say that the amount of money, like the difference of money $5. Yeah,
That last part,
I can't hear you.
you were mumbling. I mean, I couldn't hear you. And I don't know if the children could hear you too. So can you repeat what you said?
Actually, it looks like I have an audio problem. Okay. I said to explain the meaning of the range within the problem, we have to use the problem to tell a story. So people donated money at a school fundraiser, and that's what I underlined because those are very important things for our little story that we're going to tell. And for range, it's going to be the difference in how much the person who gave the most made and how much the person who gave the least made.
Right.
How much they gave. So the difference in what they gave was $55. So that's a lot for a school fundraiser. Sometimes, like if you're gonna donate money, a lot of us are donating $5. Then we have a person donating $60. So that's a big difference between the donations.
Exactly. And you don't usually get that, but sometimes, depending on the situation where you are, you probably you can.
Just like our kids can drive. We had some people donate a lot of cans. They probably just some people maybe donated a few cans just to get that $5 gift card. Just put your name in the bucket and work on out, right?
Exactly.
Now, identify the outlier in the data set and explain why this amount is an outlier.
And I think that Ms. already went over that. $60 would be the outlier.
Right, that is huge. It's way over there. And then remove outlier, range. Does the range increase or decrease? We talked about this. We talked about mean.
So if when we take the outlier out, which is $60, then our highest amount then in the data would be 30, and 30 minus 5 would be 25. So the range will decrease due to the simple fact that you took that outlier out, which was $55. It was the range at one time with the outlier in, and with it out is only $25. So it decreased by more than half.
Right, and so now we're closer together. Now it's the people, they're all around that same person who gave the most money. They're the most generous person, and then you have some people who money.
So Ms. Pitt, would that be lesson for today?
Yeah, that's it.
All right.
So the only thing left is the good independent practice for the lesson, and then our little lesson homework thing that we would do. And questions that just summarize the entire lesson. So go ahead and finish this up, guys, and let us know if you have any questions. As always, we're always here to help you.
All right, and have a great day.
Yes. All right. Bye-bye.
Bye, guys.